Houston, we have a problem.
We do.
So, mate, I'm doing a bit of modification here, which is very much within our capabilities because we are expert engineers.
Yep.
So I'll tell you the problem first of all. We are building this Cosworth engine, big power one that's going in the 350Z. Very nice conversion, that, isn't it? Very unusual conversion.
Quite cool.
And what we are using here is a piston that is supplied by the customer, which is a JE piston.
Yep.
Not very common for a Cosworth YB.
No, and difficult to get in the UK really, as well. Not impossible, but
it's
less
pretty
common.
Yeah, very difficult to get rings.
Yeah.
As we will move on to. The rings that come with these pistons are actually separate. They've got a separate part number. The ones that were supplied with this are actually the wrong ones, mate. We found that out when we obviously looked at the part number and discovered that they were for a different size. These are are these a 0.5? I think these are a 0.5 piston.
Yeah.
So, what I thought was, plain and simple, we'll just get a set of Cosy rings, mate. You can either get Hepolites or the Marlers. So the issue with that is the ring layout is actually different. So it means it's got different thickness rings on these JEs than a standard one.
Right, so you can't just buy normal rings because they're thicker, one or the other?
Reason for that, they're actually thinner,
right,
which is a good thing. We have had a look online, like you said, not available in the UK at the moment, can get them imported. Going to be about 5 to 6 weeks for the correct ring set from JE in America.
Probably a couple £100 once you paid all the import charges and all that as
Probably. Money's not really the object, but time is.
Yeah.
So we want to get this motor done for the beginning of February. So we're obviously not going to be able to get that done if we have to order them rings. So what I thought is, mate, we will go for a set of normal Cosworth rings.
Yeah.
I prefer the Hepolites as opposed to the Marlers.
Right.
Not just me, but I do believe that they are a more superior ring.
Yeah.
And weirdly, half the price. What does that tell you?
Ideal.
What we've got on these JE pistons, mate, is we've got a ring layout of 3mm thick on the oil control. We have got 1.5 on the centre, 1.25 on the top.
Right.
What the Cosworth ones are is 3mm on the oil control, which is good.
All good.
Because we haven't got to do anything to that, but it's a 1.5 middle, 1.75 outer.
Right.
Which means we have to remove, to fit these rings, we have to remove 0.25 width off the centre and the top grooves.
Right, so...
To cut a long story short.
Yeah.
So that's what I'm doing, mate.
So you've got a little sort of...
So what I've got is basically
a
grooving tool, which is basically a thin part-off tool.
Yeah.
And what I've done with that, because I've done this plenty of times before, I've actually machined that to about 1.4 thick. So what I do is I don't ever, with an aluminium piston, I don't ever just machine the tool the width you want.
No.
Because it can, obviously then it's going to remove material both sides, but sometimes it can go over.
They can drift, can't they? They're very thin, so if
they can drift, fluctuate, and So what I do is do it one size, basically smaller than any groove that you're going to need, and I run the tool very slightly offset to one way, and then just move it off the left-hand side and try the ring. So you want a nice free inserted ring, but you don't want any sort of side play. So that's what I'm doing, mate. I've done one already, which is this one here, mate, with the top ring. So what I do first of all is obviously I've got the tool set up now. See, that is a nice free fit in there. We've just got to deburr that. You've got to make sure that you get the correct depth, so the ring sits below the surface or the outside diameter of the piston.
So you don't really want to take anything off the bottom of that groove, but at the same time you need to make sure you're right up to it.
Yes, you do, yeah. So once I've set the tool, in theory, I'll do all the top ring grooves first, so I'll change the piston over and make sure that groove is running true, and then in theory, mate, just run that tool down very, very carefully until it touches the base of the ring groove. Because that's, as I say, that's another thing you need to check. You need to make sure that the ring is not actually deeper than the groove. Right. We've had that before, haven't we, on aftermarket pistons?
Yeah.
Where the pistons, great nothing wrong with the quality, except the ring groove ain't deep enough. And when you go to put the piston, you can check your ring gap, but when you put the ring on the piston and go to put the piston down the hole,
It's like
it won't close up
sticking out
far
miles,
enough,
yeah.
and you wonder why you're having to hammer it down the bore. Not that we do that. So we'll just check that, and that, mate, is a lovely fit there.
Yeah. So you don't want any slack either.
Don't want any slack.
Yeah.
So that's that one done. I'm just going to change over, mate. There's no problem at all with this method. I've done it plenty of times, mate. It's only what they do from the factory anyway, isn't it?
Yeah.
And it just means that if the customer, for any reason, wanted to change the rings in the future, then we've converted this to pretty much an original.
It's handy, I suppose. You can just chuck any rings on it.
Yeah, that's it. The advantages with these JEs, mate, say they're a good quality piston. They do come with an actual smaller bowl in there, which is a good thing because we want to run this piston at 9-to-1 compression as opposed to 8-to-1. So yeah, no problem with them at all, mate. And check that now, look, all the way round. No problems at all. And there we go. Well, my friend, I've done me piston ring grooves.
Lovely.
And you can see now it's just like factory, isn't it?
Yeah.
Absolutely perfect, that is. You have marked out, because obviously this block here, we have put oil jets in the bottom. You can see where those oil jets are placed.
Oh, if the camera focuses, you can.
Which
there you
it
go.
doesn't. And what we've had to do is these pockets, you do get, these pistons, sorry, are not like the originals. On the originals, you do get a cutout there for the oil spray jet because the base of this piston protrudes the base of the block.
Right, so do they do that for a little bit extra skirt length, just for a bit more sort of...
Yeah, so they do it when it's at bottom dead centre, it's not really, it doesn't really matter that the bottom sticks out a bit because it's probably about 10 mil up here, which is the biggest part of the piston.
Right.
So really, it's only this area here, which in theory runs in the bore.
Right,
so it doesn't matter if the bottom goes down. But the reason they probably do it longer is when the piston comes up and he's running in the bore, you're just getting that extra length. So the bottom in comparison to the centre of the pin is just long enough so it's not going to rattle about.
Yeah, so
all depending on the crown height and the weight of the piston.
So basically it helps with like piston slap a little bit and makes them a little less susceptible to it.
Potentially, yeah. What you've done, mate, is mark it so it's the pocket is slightly below the base, and then we know that we're more than enough because the oil jet probably sticks up, what, 2-3 mil above the base.
Like
this is when the block's over. So we're going to have, in theory, 3 or 4 mil of clearance there. So more than enough, isn't it?
Should be perfect.
So I've checked the weight of these pistons, mate, and they're all good.
Yep, as they normally are with the proper forged stuff.
Exactly, yeah, even with the machining that we've done on it. So I've just deburred these little cutouts. I'm just putting them on the rods now and inserting them into the block.
Lovely.
We'll have more of that on the next video probably, mate, but we just take these and let my eyes adjust because I can't see anything at the minute. But we've had another engine in, haven't we?
We have.
And we're not going to say warranty because it isn't.
No.
What this is an engine that has gone a bit Pete Tong on the dyno. So quite interesting, this one, because it is an engine that we built.
Yeah.
The engine has been running. The reason we're mentioning this is because this is like
it's a diagnostic, isn't it?
It's a diagnostic, really. So you've got a series of stages from when we've done the engine. It goes back in, it's inserted into the vehicle. This is the same sort of thing for any motor that we do usually. It then goes off as it's running procedure. If it's a performance engine, a lot of the time it gets set up, mapped, rolling roaded, something. When it gets to this stage and something goes wrong, we have to obviously do a bit of investigation.
Yeah, so the customers followed all of our running in procedure, which we provide them with. We give them all the spec sheet and everything.
Exactly, yeah. And I'm confident that he's done that correctly. He did actually bring the vehicle back when he'd done about 700-800 miles after changing the oil, after it's running in procedure. Still persisted in running it in or taking it easy because this is a bit of a track car, really.
Yeah, it's pushing quite a bit more power than standard.
Yeah,
isn't
it's pushing sort of 270 horsepower. It's a Fiesta ST, is that right?
Yeah, it's a 1.6 ST 180,
turbo.
I believe.
Yeah, so it's running about 90 extra horsepower.
Yeah.
but the engine was built to suit. So we put ductile iron liners in the block, because obviously it's an aluminium block.
Open deck as well.
Open deck. So we put those in there. We've got forged pistons, H-section rods, competition bearings, all the rest of it. And I'm pretty sure on our previous videos we've shown the bottom end being built. They installed the cylinder head, that's right, wasn't it?
Yeah, they built it up. We just built the bottom end, really.
Yeah. So basically what's happened is the thing has done a dyno run after it's been run in, etc. No problems whatsoever on the dyno. But apparently when I spoke to the guy that owns the dyno, we know him quite well, he said ran absolutely fine, no problems at all. It was only when they were taking it off the rolling road and it was idling, they noticed that it had a bit of a slight knocking down below. So it was then switched off. Obviously the customer's annoyed and upset because basically the engine has to be sort of stripped down and investigation gone on. It's this sort of scenario really where we like putting it in a video because it's important that...
Well, this is a perfect example of how we want the warranty process to go.
Yeah.
The customer's done all the things we asked in the build-up to it.
Yeah.
The problem's happened. He's come straight back to us. Yeah, he's had somebody have a look and check the issue without stripping the whole engine down. But he's brought the engine back to us and allowed us to strip it and inspect it properly.
Yeah.
And because, like you always say, you find out the most about what's happened whilst you're stripping it down.
Exactly.
It's totally different when you look at a load of parts on the table.
Yeah.
But you notice patterns and you see things as you strip an engine down.
Yeah.
So
it's trying to educate that customer subtly, and while you're going through this warranty procedure, to convince them that we need to have a good look as to what's happened, have a good look in the engine, because you can tell a lot. It's all very well fixing the engine.
But we need to work out why.
Yeah, you don't want it to happen again, so it's very important.
And we need to work out if
strip
it's
it down.
something we did in the machining process, or if it's something that has gone wrong post-build to do with some other running condition, or
you can
like
tell
that.
a lot when you're stripping an engine, even from the cleanliness of the engine, the oil. That's why we always state that if a customer takes it upon himself, if they've lost confidence, take it upon himself to go and get it stripped elsewhere, then bring it back. It's no good, because
we can't. Yeah, we need to see it on as it's being stripped down, because you see things, you see the debris before everything's been washed and cleaned and sorted out.
That's right. Yeah.
You find evidence of problems.
And this engine is a prime example of why that needs to be done, isn't it, really? Yeah. Going off the mapper's train of events, really, as to what happens, what we're looking for, first of all, we obviously remove the cylinder head. We're looking at the gasket, we're looking at the block and the head face to see whether it's blown a gasket, and what's happened there.
Piston crowns and everything as well.
Yeah, secondly is the piston crowns. You can tell a lot of the piston crown. We all know that a lot of engines, especially these modern ones that run a tight tolerances on everything, and are very critical on the oil viscosity, etc. They can. It doesn't necessarily have to be an oil issue to make a big end go or a crank go. It can be load on the piston, so that can be things like ignition timing, fueling, anything like that.
So what basically happens is excess load, or like detonation, anything like that, it can literally squeeze the oil film and push the oil outside of the bearing.
It can
which
indeed,
emulates an oil starvation issue.
That's right, yeah. So that's what we're looking for, any signs of debt, any sort of running issues on the piston crown, on the spark plugs, cylinder head, combustion chamber, things like that, really.
Yeah.
So we've checked all that, and we were pretty confident that the thing's been running pretty good.
Yeah, it looks pretty good. Maybe a tad rich, but
then again, it could be it could have been running rich at some point.
Yeah. And a lot of turbo stuff does run rich, especially when it's not on boost.
Exactly, and when it's been doing a mapping session, bear in mind it could have been running rich off a base map or something.
Yeah.
And then once they've got the fueling okay, it doesn't give it enough time for the plugs and that to clear, so it all could give symptoms of running a bit rich. But a lot of the time, running a little bit rich is not a bad thing. Some mappers even sort of set the things up to run a little bit rich, especially up the rev range, just so they run a bit cooler and safer.
Yeah.
So we're confident there that that's sort of okay. First thing we noticed in the sump. Now, bear in mind this thing has not done many miles, probably 1,000 mile, 1,100 mile.
Yeah.
Had about 3 oil changes, so it's been you know, meticulously sort of looked after within them running in periods. But where is the sump?
Oh, the sump is on the bench.
Sump's on the bench.
The
And the first thing we noticed was, obviously you drain the oil through the drain plug, but on these particular sumps, thankfully,
well, on a lot of sumps, really, it's sort of...
there's a lower section which is literally 2 or 3 mil lower than the actual drain, so you wouldn't be able to drain all of it out. And there is a particular, ignore the bits of shell, but there's a particular sort of goop in the bottom there.
Yeah, and you can actually see, if you tip it up like that, you can see the clean oil and the sort of sludge separating.
Yeah, so this oil in the base of the block here is that type of oil that's been overheated. It's turned into a goop. So
basically, you only get the goop when the oil breaks down.
Yeah.
And there are only a couple of ways to do that. One is literally just sheer like mileage.
Yeah.
And the other way is just getting too hot.
Yeah.
And we all know that turbo cars do like to cook the oil a bit.
That's the thing, yeah. So we're suspecting at this stage, if the oil's got hot at some point, whether on the dyno or at some stage, the oil has got hot to the point where it's not doing a great deal. Our next findings were the main bearings were worn slightly.
Yeah.
Not disastrous. All the clearances were absolutely fine. So whether that's the way they've worn is a result of the oil sort of getting thin.
It could have even been sort of before it was first fired up. If it took a minute to get oil pressure, I don't know. It could be something like that as well. Just sort of polished a little bit, isn't it?
And then we have got so this is the front of the engine where the oil pump would be on the end of the crank.
Yeah.
And we have got 1, 2, 3 and 4 sets of big end shells, and you can see they progressively get worse as we get to the back. 4 being the culprit for the engine failure. Down to the copper, some of the copper backing has started to peel away. But usually, if it knocks a crank out on any sort of revs, it's going to more than likely damage the crank journal, as in the size of it will go down. If it's bad enough, it can bend the crankshaft. And almost certainly, what it always does is damage the rod. We've had many people coming in the past saying, can I have a set of shells? My rod's perfect. And we're like, it ain't. It's knocked it out, and that thing's going to be either oval or oversized. Weirdly on this, which does correlate correctly to what the mapper said, that it started knocking on idle and they turned it off. The crank journal and the rod housing measure absolutely fine. The rod housing has got blue where it's got hot, but the housing is not ovaled. If anything, it's very slightly smaller where it's got warm and sort of shrank down, but it's only fractional and it's not oval. So my verdict is, he was right in what he was saying. This has not happened under any sort of load because that housing had been knocked straight out.
Yeah, and the journal, we've measured that as well, and the journal's all good.
So. Journal's all good as well. So the rod can be resized and cleaned up, although we obviously are going to suggest that they put a new rod in it.
Yeah.
But I have no problem with rectifying that rod. The crank just needs a polish, measures perfect.
Yeah.
So in some respects, he's got away with this very lightly.
Yeah, it was lucky it went, well, it's lucky they noticed that it had gone on idle.
Yeah.
And didn't sort of drive it away or try and rev it up again or anything like that. And because it's probably what saved it. They just switched it off and thought, let's not do anything with that for a minute.
Exactly. So what we're going to be doing is rebuilding this. We are going to be looking at a different oil viscosity. I think he was running a standard oil viscosity, which is obviously not good enough.
Yeah.
And we don't know what temperature the oil was running at the time. So
well, and you know, obviously on a dyno, yes, they've got their big fans and everything, you know, hopefully pushing enough air into the engine bay, but you don't know whether it's enough. It might be that it got hot. These don't really, I doubt he's got a oil temperature sensor or anything like that.
Maybe not.
And you can you can see there, it's just oil is thinned out, and the further away from the oil pump it is, the less oil it's received.
Yeah, you probably find it started to do it while the revs were up at some point, but with the raising oil pressure, you're not going to have as much of a problem. But obviously when the revs drop and the oil pressure goes down, it's just enough to sort of grab it. There's not enough oil there to cool it. So in a way he's lucky, a bit frustrating we've had to take the engine out and strip it, but set of shells, bit of machining, which will skim the head, obviously check the head out, skim the block very slightly, and
yeah, I mean, it could have been new crank, new rods, new pistons, new head.
could have been.
It could have been.
Could have been a disaster. So in a way, he's quite pleased in that respect.
Yeah.
So yeah, I would say different oil grade.
Did you say it was what oil it was?
He was running a 520.
Which is probably what these run standard, isn't it?
I would suspect
Before
so,
you
yeah.
start
But
pushing
not
more
really
boost
good for
and-
that sort of.
Yeah.
So there we go. Diagnosis done. You've done a report.
Yep.
Customers give us the go ahead, so we should be getting this one complete within the next week or so.
Ideal.
There we go, mate.
Proper
That's
job.
it for one video this week, isn't it?
Yeah.
Thanks a lot for watching, guys. See you in the next one. Cheers.